Welcome to video 1 for this unit on angles, triangles, and prisms. In this video, we're going to focus on angle relationships. When two lines intersect and form four equal angles, we call each one a right angle. A right angle measures 90 degrees and is marked with the symbol for perpendicular lines. You can think of a right angle as a quarter turn in one direction or the other. One full turn is the same as 360 degrees. Here is a straight angle. A straight angle is an angle that forms a straight line. It measures 180 degrees. A straight angle can be made by putting right angles together. You can also think of a straight angle as a half turn, so that you are facing the opposite direction after you are done. If you put two straight angles together, you get an angle that is 360 degrees. You can think of this angle as turning all the way around so that you are facing the same direction as when you started the turn. When two angles share a side and a vertex, and they don't overlap, we call them adjacent angles. Adjacent angles share a side and a vertex. In this diagram, angle ABC is adjacent to angle DBC. The angles share the side BC and the vertex B. These angles do not appear to be straight angles or right angles. Let's use a protractor to measure the turn of one of the angles. Angle DBC appears to be smaller than a right angle, so we expect the measure of the turn to be less than 90 degrees. By aligning one of the sides of the angle with 0 and following the path of the turn to the other side of the angle, we see the measure of the turn is 70 degrees. When we measure the other angle, we see that it is 89 degrees. We can add angle ABC and angle DBC to find the measure of angle ABD. Angle ABD is 159 degrees. Complementary angles are a special type of angle pair. Complementary angles have measures that add up to 90 degrees. Here are some examples of pairs of complementary angles. We can also write equations that represent relationships between angles. If we assume this angle is a right angle, then these angles are complementary, so we know that z plus 64 equals 90. Supplementary angles are another special type of angle pair. Supplementary angles have measures that add up to 180 degrees. Here are three examples of pairs of supplementary angles. Since the last pair of angles, x and 42, form a straight angle, they must be supplementary. So, x plus 42 equals 180. When two lines cross, they form two pairs of vertical angles. Vertical angles are opposite angles that share the same vertex. They are formed by a pair of intersecting lines. Their angle measures are equal. We can see this because they are always supplementary with the same angle. For example, both of these 30-degree angles are supplementary to this 150-degree angle. This is always true. A plus B equals 180, so A equals 180 minus B. C plus B equals 180, so C equals 180 minus B. That means A equals C. We can use all these angle relationships to find an unknown angle measure. Let's write and solve an equation that represents this situation in order to find the value of x in this diagram. Using what we know about vertical angles, we can write the equation 3x plus 90 equals 144 to represent this situation. Then we can solve the equation. The value of the angle x is 18 degrees. Thank you for watching video 1 of 4 for this unit on angles, triangles, and prisms.